Hello, in this video we're going to look at another aspect of statistics, and that is the aspect where we try and take that data and try and summarize it down to a single number or a single set of numbers that will allow us to get some ideas to what's happening with that data. The things we're going to look at here are what we call measures of central tendency. We're also going to look at one other way of visualizing data called box and whiskers plots. So let's go ahead and get started with those ideas. Okay, so we're going to start by looking at measures of central tendency. And these are basically just ways in which we can take a set of numbers and boil it down to just one number that sort of represents the center of that set of numbers. We have three ways of doing that: the mean, the median, and the mode. The one that you're probably most familiar with is the mean, which is also known as the arithmetic average, or sometimes you'll just see it referred to as average. So when they talk about finding the average of a set of data, typically what they're doing is they're saying, let's find the mean of that set of data. And the way we would write that is we would say x bar, and the x bar represents the mean, that's the way we would write mean, is equal to, we sum up all the numbers, the sum of all numbers, divided by how many numbers there are, so the number of numbers. Okay? And it's the only one that's got a formula that goes with it. But really what we're doing is, if we think of a way of defining this other than just the formula, what we can define it as is the balance point of the numbers, or of the data. So if you were to think of that data as being on a number line, and that number line was just, say, a ruler or something, or a piece of wood, and they were all spread out the way that they should be evenly, then if you were to put some, and they were suspended in space, if you wanted to balance them on one point, that point would be the mean, or the arithmetic average, because all the data on either side would balance each other out. The second type of measure of central tendency is the median. And the median is the middle number in an ordered, and that's the key word, an ordered set of data. Alrighty, and if we've got an odd set of data, it's pretty easy because you just take the middle number. But if you've got an even number of data points, then you have two numbers that are in the middle. And so if even, what you do with those two numbers that are in the middle is you find the mean of the middle numbers. Okay, so you just find the mean of those two numbers that are in the middle. And lastly, the mode is the number that occurs most often. And it has to be more than once. And there can be no mode, there can be one mode, or there can be multiple modes. If you have all the numbers and they're just listed once, then there would be no mode to that set of data because there's nothing that occurs more often than once. If you have just one number that occurs most often, that would be your mode. Sometimes you'll get numbers where there's several of them that all occur the same number of times, and it's the most often. And those could all be the modes. All right, so let's look at an example. And our example is a sample of college students were asked how many vehicles their immediate family owned, and they reported the numbers that are listed below. Find the mean, median, and, oops, that should be mode, typo, of the data, and choose the best measure of center and explain why it was chosen. So let's start off with the mean. Remember, the mean is the sum of all the data, so we would take 1 plus 18 plus 4 plus 3 plus blah, 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 all the way down to plus 2 plus 3. and we would divide it by how many data points there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if we add all those up, and I did that, and I got 53, and I have 15 numbers, so when I divide that out, I get a mean of 3.53. If I want to look for the median, what I've got to do, I've got to start by putting all of those numbers in order. So when I look at those, let's see, I've got 1, 2, 3 ones. I've got 1, 2, 3, 4 twos. I've got 1, 2, 3, 4 threes. I've got 1, 2, 3 fours. And then I've got that 18. Must be a car collector or something, I don't know. Alrighty? Now when I look at that set of data, I've got 15, so if I go in 1, 2, 3, 4, 5, 6, 7, the 8th number in from either side, 1, 2, 3, 4, 5, 6, 7, 8, should be my median. And so my median in this case is going to be a 3. And then my mode is going to be the number that occurs most often. And notice 2 and 3 are both used 4 times, and that's more often than anything else. So I have 2 modes. I have 2 and 3. Now when I look at those numbers, I might say that 2 and 3 are the best measure of central tendency, because that's almost all the numbers are right around them, and those occur the most often. So we could make a real good argument for 2 or 3. We could also make a pretty good argument for 3, saying, well, it's a little skewed to this side, so maybe that's why it should be a 3. This one, notice, is way over here, and it's skewed by that 18. And one of the problems with mean is that it is skewed when you have large numbers that are sort of disproportionate to the rest of the data. Sometimes the mean is going to be the best measure of the central tendency. Sometimes the median is. Sometimes the mode is. Kind of depends on the data that you're working with. All right. The next example I want to look at is another way of dealing with means, and it's the following example. Assume that your psychology class grade is based solely on your exam score average. You currently have the following scores, 84, 91, 67, and 77, and you would like to earn a B, which is 80% or better in the course. So what score would you need on your last exam? So we've got 4 exams already, and there are 5 exams total. And we know what we would like for our mean. So remember, we said that mean is equal to the sum of all numbers divided by the number of numbers. And before, we knew these 2 pieces, and we just plugged them in and found the other. This time, we know the mean. We would like to know, how do we get an 80%? We know some of these numbers. We know the first 4 exam scores, 84, 91, 67, and 77. But we don't know that last exam score. So what I'm going to do is I'm going to put in an X for that last exam score. And then I know that I've got 5 exams that I'm looking at. And now I can solve this equation and find out what that last score is. So I'm going to solve this equation. I'm going to multiply both sides by 5. So that's going to give me 400 equals, when I added all of these up, what did I get here? My notes. I got 319 plus X. And now I can solve that. And I'll get X is equal to 81. I need an 81 or better to get an 80% or better in the course. All right, so sometimes you're going to be finding the mean. Sometimes you can use that formula to find other things. The other thing we want to look at in this section is what we call a 5-number summary. And we use that in order to find another visualization, which is the box and whisker plots. And the 5-number summary consists of these 5 things: a minimum, a maximum, a medium, a first quartile, and a third quartile. And the minimum, well, that's pretty straightforward. That's just the smallest number. The maximum is just the largest number. The median, well, we can see above. We talked about the median. It's just the middle number in the ordered set of data. The first quartile, which is usually labeled Q1, that is the median of the lower 50% of the data. And the third quartile, which is labeled Q3, is the median of the upper 50% of the data. Okay? And the way we write these typically is we will say what our minimum is, what our Q1 is, what our median is, what our Q3 is, and what our max is. Okay, that is our 5-number summary, and it kind of gives us an idea as to how the numbers are spread out a little bit. So let's look at some data that we've already seen before. Alrighty, and I'm going to start with this set of data, but in order to make it just a little bit differently, because I want to look at something specific, I'm going to write this. I'm going to take a number out. So let's say let's take one of the 37s out. Okay, and I'm going to do that just so I have a different number of numbers in each of these, so I can kind of see how these work. And I'm going to list all these numbers. So if I go back to my stem and leaf diagram from before, I can pull all the numbers off. Okay, and what I'm going to do is I'm going to eliminate one of these 37s and pull everything else off. All right, and I'm just going to list them in order from smallest to largest. So I have 31, 36, 37. I'm going to take off one of the 37, so I only have 2 of them. 38, 38, 39, 40, 40, 47, 48, 48, 49, and 52. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14 data points. And what I want to do is I want to write my 5-number summary. So the first one, that's easy to find. That's a 31. Okay. I'm going to need my Q1. I'm going to need my median. I'm going to need my Q3. And then my maximum is 52. All right, so let's see if we can figure out the median first. So since I've got 14 data points, I go in 7 from both sides. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And my median is going to be right here in the middle. All righty? So if my median is right there in the middle, it's going to be 39.5. All right? That's my median. And now notice that breaks the data into an upper 50% and a lower 50%. And then for each of those sets, I'm going to find the median of both of those, and that's going to be my Q1 and my Q3. So here I have 1, 2, 3, 4, 5, 6, 7. So the middle number right here is going to be 37, and that's going to be my Q1. And then the middle number here is going to be this 48, and that's going to be my Q3. Now go ahead and take a moment and you do the next one and do it for all the numbers. So we've got all 15 numbers instead of 14 numbers. And go ahead and come up with your 5-number summary, and let's see if we get the same thing. Okay, so here's what I got for this one. Put all the numbers in order. And then since I had 15 this time, I've got one number in the middle. And again, that's going to break the data into 2 pieces on either side. And of these 7 data points, I found the median of that set, and I found the median of that set. So here's my minimum, 35. My Q1, which is the median of the lower 50%, is 40. My median of the whole thing is 47. Median of the upper part is 50, and the maximum is 73. And what you can do with this is you can create a visual for looking at these and use that to compare these numbers. All right? So here's how we would set up our visual, called box and whisker plot. And let's say I'm going to start at 30, 35, 40, 45, 50, 5, 60, 65, 70, and 75. And what I'm going to do is I'm going to start and put points on each of these numbers. So I'm going to start with this one first. I'm going to put a point at 31, another point at 37, another point at 39.5, another point at 48, and another point at 52. And then I'm going to take those first 2 points and connect them with what I call a whisker. Take the next 2 points and connect them with a box. The next 2 points, connect them with a box. And the last 2 points, connect them with a whisker again. And the way this is set up is this is 25% of the data is in this part. 25% is here. 25% is here. And 25% is there. So it's just a nice way of visualizing what we have happening. If we make the same thing for the next one, we have a point at 35, at 40, 47, at 50, and at 73. Way the heck down here. So I make a whisker, make a box, and make a whisker. Alrighty? And you can see that these look pretty different. I mean, everything here is kind of compact and close together, whereas here we've got this way long whisker out here. And if you look at our numbers, they're pretty skewed towards the right. That's the years when they were talking about steroids, juiced ball, and all that sort of stuff. So what we'd like to do is we'd like to talk about outliers. And outliers are data points that skew our data. And in order to talk about them, what we need is something called an IQR. All right, which IQR stands for interquartile range. And it's basically how big is the box. So it's Q3 minus Q1. And outliers are defined to be 1.5 times IQR above Q3 or below Q1. Okay, that's how we're going to define it. So if we look at the IQR for the first one, let's see, our two numbers are 48 and 37. So 48 minus 37 would give us our IQR, so it's 11. And then 1.5 times that would equal, let's see, 16.5. And so we want to take our Q1, which was 37, and subtract off 16.5, which would give us 20.5, and see if there's any numbers that are less than 20.5, and there aren't. And then we want to take the Q3, which is 48, and add 16.5 to it. So 48 plus 16.5 gives us 64.5. And there are no numbers that are above 64.5. So in this case, for this one, we have no outliers. Now we're going to look at the other one and take a look at its, whether there's any outliers for it. So we start out with the IQR for the second. And it's going to be equal to 50 minus 40. Which is equal to 10. And so 1.5 times the IQR would be equal to 15. And now we want to look 15 below 40 and 15 above 50. So 15 below 40 give us 25, and there's no numbers that are less than 25, so we don't have any outliers there. But 50 plus 15 gives us 65. And notice we have two numbers which are above 65, so those are both outliers. 70 and 73 are outliers. Alrighty, so that's how we find whether we've got numbers that are going to skew our data. Now let me show you one more thing on the calculator, because this is pretty nifty. And I'm going to have my 5-number summaries here. So let me put those there and put the calculator right here. Okay. Now what I've done is you can go into the stat mode on your calculator, and we'll show you more of this later. But if you go into the stat mode, which is right here, you can edit and put in a list of statistics. So I'm going to choose Edit. And what I did was in L1, I put all of those numbers from 75 to 89, and I took out one of those 37s. I took out this 37 right here. And I've got all of those numbers listed there. And remember, we had 14 of those right there. And in L2, what I did was I put all the other numbers from 90 to 2004, and I've got all of those in there. And now what we can do is we can actually use the calculator to find a lot of different statistics. So if once I've got those in there, then I'm going to go to Stat. I'm going to move over to Calculate, and I'm going to use one variable statistics. And I'm going to start by looking at L1, so I'm going to hit second and 1. Notice there's an L1 there. And I'm going to hit Enter. And what it gives me is, notice the first thing it gives me is X bar. Remember we said that that was our mean? So that's our mean for the set of data. This is the sum of all the data points. That's the sum of the data points squared. These are two different standard deviations. We'll talk about those in a later section. This is how many data points, the number of data points. And then if we scroll down, we actually have our 5-number summary. We have 31, 37, 39.5, 48, and 52. And if we look over at our data here, 31, 37, 39.5, 48, and 52. If I look at the stats and calculate the one variable stats for L2, which was that second set, I hit second and 2, which is L2. Again, it's going to give me some data up here. I've got 15 data points now because I didn't take anything out. And now I've got my 5-number summary again. 35, 40, 47, 50, and 73. Pretty nifty. And we'll come back and look at least these two things later on. All right, so I hope that helps.